Continuing with part 5 about the vertical line test, let's go ahead and look at Theorem 2.2, which is a statement of the vertical line test. You'll oftentimes see me refer to it as the VLT. That'll be a abbreviation for the vertical line test. And it says that a curve in the Cartesian coordinate plane is the graph of a function if and only if no vertical line intersects the curve more than once. So the way that this theorem is going to be used for us is that we are going to be trying to show that a graph is a function. So this is what we're trying to show. And in order for us to be able to show that, we have to be able to prove that no vertical line intersects the curve more than once. So what I have underlined here in red is what we call the condition. So if I can show that that condition is true, then that means that I have shown that my graph must represent a function. So the words if and only if separate the theorem into these two halves, these two parts. So let's go ahead and look at example 2.7, and we're going to use this theorem directly. It says here, determine if each curve represents a function. So notice how this is different compared to example 2.6. In 2.6, you had an equation and you did not have the graph, whereas here we have the exact opposite. No equation, but we have the graph. So the vertical line test becomes a really good way to determine if something is a function. Take a look at picture for part A. If I was to draw a vertical line right on top of the y-axis, I would find that my vertical line crosses the curve more than once. It crosses twice. Now, the reason why this is of concern is because analyzing the ordered pair, that first ordered pair is located at 0, 2. The second ordered pair is located at 0, negative 2. So if I think about this from a arrow map perspective, my first set I'm pulling the value 0, and then from my second set I have the numbers 2 and negative 2. And these two ordered pair would suggest that 0 maps to 2 and it also maps to negative 2, which means it violates our understanding of the uniqueness for a function. So I didn't want you just to memorize the vertical line test as a rule. I want you to understand why it is this rule. It's because it's based off of the function definition. So here's evidence of why it works. So the conclusion here is that this is not a function. That's our conclusion. Let's look at B. If I start drawing vertical lines, and I can draw them anywhere, every time I draw a vertical line, it's only going to cross the curve once. So this is an example of a function. So I will write is a function. Take a look at part C. Start drawing vertical lines, and I know that my lines aren't perfectly vertical, but you can imagine that they are. And if I was to draw them, they would all cross only once. So C is also an example of a function. But part D may be a little more challenging. If I look at part D, I might draw a vertical line right here where x is negative 3, and I can see that my curve crosses once. And if I only draw one vertical line, then I may falsely believe that this is a function because it only crosses once there. So in the theorem it says no vertical line intersects the curve more than once. That means I have to really be considering every conceivable possible vertical line. So if I can find a vertical line like the one that's here in between 1 and 2, that one does end up crossing my graph more than once. So all it takes is one vertical line to cross more than once, and now I can say that this is not going to be a function. So that is the conclusion here. This is not a function. And that is the vertical line test.